So good afternoon, everybody. See, my topic is the cost-effective technology for the making the infection control and in a modular operation theaters, ICU, NICU, wherever you want. We are mainly working for the airborne infections. As my logo also had mentioned, the airborne infections, and we are working for the indoor air quality. So this is one of the product which you are seeing is the ceiling suspended AHU with the laminar airflow systems. Okay. This is the world's first ductless air handling unit along with the laminar airflow systems. The technology what we have developed is according to the NABS guideline. We had followed the NABS guideline 100% in my systems. In the NABS guideline, they said that the class 5 has to be maintained, class in the operation theaters. We are giving even the class 10,000s in operation theaters. So that will be the better than the 10 times better air quality. We are talking about the electricity and the cost effectiveness. How much you are expecting poverty you have to save in the electricity? Anyone? This system is saving almost 8,30,000 in a 1 year in a operative maintenance cost in electricity only. So that is there. Then the maintenance, AHU maintenance is also one of the big subject. We had developed the technology which having the negligible maintenance, or you can say the no routine maintenance is required for the systems. Then to avoid the surgical site infections and post-operative antibiotic dose, that is our first concern to minimize, how to minimize these things. Then whatever the data we are giving, we are showing in a digital display, which will be also saved in a cloud. You can also take in a lens to your systems. So whatever we are claiming or whatever we are maintaining in the operation theaters, you can have the records with you. You know the importance of the NABH and how to means going with the NABH. What are the importance and benefits to your patients, your organization, and the staffs. I will talk about what exactly they are given in the requirements in the NABH guideline. They said that the minimum 20 air changes has to be maintained. Our system will not give only 20 air changes. You can have the 20, 25, 30, or 20, 30, 45, whatever you want. We can give accordingly. We have the air setting VRF. We are given VFD inside variable fan device, so you can control the fan speed, and according to that, you can maintain the air changes in your operation theaters. Apart from that, they said that the terminal HEPA has to be come through the ceiling. So my system having that much, because this is a ceiling suspended systems. Then they said that the airflow, what airflow has to be maintained in a operation theater. Near the HEPA, it should be around 90 to 120 FPM. But on a table level, it should not be more than the 25 to 35 FPM. So that is maintaining by our systems. They said the minimum 2.5 Pascal they asked, but our systems can give up to the 15 Pascal positive pressures. Then the three-stage filtration they had asked, 0.3 micron, 5 micron, 10 micron. We had added one more in that is the activated carbon filter also we had added. And temperature they said around 21 plus minus 3, and the humidity between the 20 to 60. These are the things they are given in the NABS guideline. In the design point of view, what they had mentioned is that the AHU of each OT should be the dedicated one. It should not be combined with the adjacent area. That is more important, because the other rooms infection may comes to your OT. Then they said that the outdoor unit you have to keep in such a places where the exhaust and the DJ exhaust or the parking where the dusting you are getting. So because of that, your outdoor unit may get choke. Condensing coil may get choke very fast. So cooling may get hampered. They said that the window split AC should not be used in any type of operation theaters, because they said that any type of operation theater, because they are pure recirculating unit, and what will happen? See, you cannot maintain the sterility with that because they are only in circulating the internal air only. Okay. And further, they said that where the space is constant, that the word had they put it, but they said that ceiling suspended AHU is provided. There is the accessibility for the maintenance of the filter and other parts of the AHU. One more point they had mentioned that during the non-functioning hours, AHU blower will be the operational round the clock. Anyone, why they are saying like that? See, I wanted to interact with you people so that I can solve your all the doubts and concerns making the operation theaters. So they said that during the non-functioning hours, AHU blower will be operational around the clock. Why? If they don't do that, what will happen? If you don't maintain the air circulation around the clock in the operation theater, what will happen? Yes. See, the thing is that if you don't maintain the things, the condensation will happen inside the duct. And fungus, bacteria, tremendous growth will be inside the duct. So, to avoid that, to avoid the condensation, to avoid the growth inside the duct, fungus, bacterial growth, they said that during the non-functioning hours, you have to maintain the flow inside the duct. You know the ducted system, how it looks like, what is the flow. This normally there is you can see, this is the ceiling, then these are the return ducts, AHU is here. To make the ducted systems, you have so many challenges also. You know what are the challenges mainly? They are bigger in size. Then the chances of air losses is always there because of the wear and tear of the ducts. Then the ducts become dirty because you have fungus, bacterial growth inside the duct. That chances is always there, and it restricted flow and making the beams and columns are there. So design point of view also there that so many challenges are there. You know the bigger size. So to maintain, you require the space also is one of the main expense. You have to give mainly on a terrace, or if the number of OTs are more, you have to plan the service floor also. So that is also one of the big expense. Then these are the problems you know with the ducts are there, always there. Initially, when you make the system, your system look like this. But after the year, it become what you say, the lot of fungus, bacteria growth inside the ducts you can see. This makes almost 1 inch inside there is the layer. Then after the period of times, rust, because of the rustings and other things, it get deteriorated like this also. This is also one of the problems you might be knowing. Whatever the inside the ducts, they are coming in your rooms and can cause the infections. So we will now talk about the solutions. Okay. See, this is the ductless systems. I will take you first. This is the return area. It's sucking the air. 20% fresh air is also coming in this chamber. In between there is the cooling coil. And this is the HEPA filter, supply area. HEPA and the activated carbon also given in this area. Normally the installation has been done like this. You have to take the 20% fresh air in the first chamber. Here is one of the fresh air damper. Is the internal air get also getting the sucked over here. Both air get mixed over here. This is the first is the mixing chamber. In this mixing chamber, we are given the negative ionizers and the UV lights. Further, we had given the fresh air damper also here. In between is the cooling coil. This is the backward curve fan, sucking the air from the cooling coil. from this HEPA, it will come on the table level, but before that, there is the activated carbon filters also in this area. I'm showing you what is the how the airflow is maintained with the smoke test. See now, with this machine we are creating the smokes and putting in the room. So to get the visualization with the color effect, we had give means the darkness is there, but you can still see the things how that smoke is not going up, that's coming down. Normally the smoke goes up. So when we are creating the smoke, that is not going up from the HEPA flow, that's coming down. Okay, that's not going up. So just to recall it again, fresh air coming in this area, this is the mixing chamber where the UV lights and the negative ionizers is there. Here we are given the auto cleanable pre-filters. The pre-filter what we are given before the cooling coil, and the one we are given near the fresh air damper. Then the cooling coil is there, which is the backward curve fan. This is sucking the air from this area, and from this HEPA and the activated carbon filter, it will come on the table level. So this is the airflow pattern what is getting created with the systems. So mainly what are the benefits with the system is that it's very compact, can be around 4 feet by 7 feet. If the area is bigger, you can give the 8 by 6 also. For the 20 by 20, we are giving the 8 by 6. But for the small OTs like 200 square feet, we can give the 4 by 7 also, where the depth is only 1.5 feet. So compact. I can say this is the versatile technology because you can connect the system with the DX coil, you can outdoor units, you can connect with the VRS system also, and you can connect if you want the chiller if you have, we can do the chiller system also, which can be connected to the chiller. And column, beams, nothing will be the challenge in your operation theaters. Whatever the way you have the operation theaters area, we can design according to your requirements and can be given. Sustainable technology is more important because the life of the AHU, what you are normally using, is not more than the 6 to 7 years. They get rusted and spoiled with the cooling coil having the water, so because of that they get rusting from the inside. The technology what we have developed will not get the rusting for the lifetime. The material what we use for the making the AHU is the ACP paneling, aluminum profile, acoustic material, then the stainless steel tray and the stainless steel grills, so nothing will get spoiled. As more important that how to save the energy, so that this is one of the energy efficient system. I will come in the next how what systems we had given for the making the energy efficiency. And negligible maintenance, operative maintenance. See, as I told you, the first area in the 1/3 area of the AHU, where the cooling, this is the mixing chamber. Then we had given this is the negative ionizers and the UV light also given in this. Then the phase damper is also coming in this area. This is the supply area where the HEPA filter and activated carbon filter we had given, which will maintain the 90 to 120 APM flow on a grill level, and on the table level it will be around 25 to 35 APM. In the fresh air damper, we had given the air heaters also. So now this is the rainy time. To maintain the humidity in the OT is one of the big concerns. So in the monsoon time, already the moisture level is high in the air. So to avoid that, means to take care of that moisture, we had given the air heaters. Then this is the fan, which will be the auto cleanable, and this is the area where we are putting the fresh air dampers. Three-stage filtrations also we are giving. 0.5 micron activated carbon filter and HEPA filter, which is the mini plate HEPA filter we are giving. Then this is the area where before the cooling coil we are giving the pre-filters, and this is one of the filter which we are given on the fresh air damper. So these two filters is connected with the tubings. You can see what we have done. We have done the one small reservoir of a half liter where the motor is also there. When you on the system and off the systems, when you off the system, the motor will start, and within a minute both this filter will get pressurizedly clean. So this is the washable cleanable filters we had given. So both this filter will get clean. So routine maintenance is totally taken care of. Normally, what is the maintenance in the AHU? You have to clean the pre-filters. You have to clean the cooling coils. These things is taken care by the system. Okay, so routine maintenance is not there with the AHU. Now, then what is more concerned that the water may come from the tray or the systems on a table level. To avoid those things, we had given the 3, 4, 5 systems we had mentioned over here, because cooling coil we had given the 30 mm slope. So, and this is the 1 inch outlet we had given. Complete stainless steel tray is there with the proper insulation. Then from this level to the your false ceiling level, almost 100 mm is there. So you can have the proper slopes so that the water will go with the proper sloping. Apart from that, we had given the auto drain wall. So the water after every 10 minutes, 1 minute it will start, and it will clean all the it will drain down all the waters from the tray. So this is the additional safety systems we had given. So there is no chance of coming the water on it from the tray of the cooling coil. Full body is properly insulated with the FR grade insulations we had given. So fire retardant insulation has been given. So there is no chance of getting the condensation inside the AHU. Then this is the PRD. You know that the importance of the PRD. If you don't put this PRD in your OT, you will not get the positive pressure. Why? See, if the fresh air is coming from the until and there is no pressure release damper, fresh air will not come inside. Okay. So this is also one of the important part. See, normally you are seeing the AHU having the 5 kilowatts motor, 7.5 kilowatts motor. We had given, according to the size, 200 to 400 watt only. So almost 25 times less electricity is required with the systems. Instead of 5 kilowatts, only 200 watt. Then VFD had been given. So we can give the 20, 30, 40 air changes according to your requirement. If I give the 40 air changes, what will happen? Instead of 20 air changes, if I give the 40 air changes, what will be the benefit? One thing is that if you have the 40 air changes, within 15 to 20 minutes, your OT will be the air quality will be achieved. And you can take your patient within 15-20 minutes. So preparation time will be less. You don't have to wait. So initially, before starting, you can start with the 40 air changes, and then once your patient is in, you can take it to the 20 air changes. Another thing is that in a particular time, you require the less temperature. For example, at the time of cementing, you required 16 degree. So to bring down that temperature immediately, if you put it on a 40 air changes, air flow will be the fast, so cooling will be achieved very fast. So this is the another benefits. Then the tonnage requirement will be also less. Normally, the ducted systems required 11 tons in a 20 by 20 operation theaters. This can be achieved with the 8 tons also. After the considering that the output ambient temperature is the 50 degree. In the some area, in this year, temperature goes up to 52 also. In the Delhi and the Lucknow area, the temperature goes up to 52 degree. Even that time, you will not find the cooling problems. Then the condensing coil, what we are using in my system, cooling coil, which we are using with the higher fins area, or means copper pipe, what we are given for the making the cooling coil. Normally, most of the companies, big companies also, they use up to that, they are taking around the 3.5 square feet per ton. Instead of that, we are given the 4.5. So if the cooling area is bigger, you will get, if the ambient temperature is more, you will not find any load on the compressors. Apart from that, we are using the blue fins cooling coil. So life of the cooling coil will be not less than the 15 to 20 years. Here is one small calculation I had given for the ducted systems. If I use the system for the 6 hours in a day, 6 hours normally we are using for the operation theater, then how much will be the electricity consumption in the working hours and the non-working hours? Because in the non-working hours, you have to maintain during the non-functioning hours, you have to maintain the flow. So that time, what normally the NABS suggested, that you can have the temperature control, that you can increase the little bit temperature after instead of the 24, you can go up to the 28, 29. And another thing is that you can run the fan with a 50% efficiency. So if I calculated that with all these things, you are going to say almost 50%. No, it's not going to be, it's less possibility that you can save the 50%, but if I calculate 50% efficiency, you are running, so 50% will be the electrical expenses, you are cutting the expenses. Then also, if you do the calculations, for the 6 hours is the running hours and 18 hours is the non-functioning hours for the outdoor unit and the AHU. So it comes to the 10,32,000 in a year. With my systems, before I had calculated the 1 hour before you have to start. So I had calculated for getting the 20 air changes, you required the 1 hour. So 1 hour added in that, even though you can have the electrical consumption comes to 2,02,000. So you are going to save how much in the electricity? 8,30,000. Then the maintenance point of view, ducted systems required, AHU required the more maintenance cost. AMC, CMC cost is also very high, goes up to 1 lakh rupees. In this, I had calculated just 50,000 rupees. Then you have to change your HEPA every 6 months. Okay, you have to validate your HEPA every 6 monthly. So if you take the cost of that, here my HEPA has to change once in a 2 year or 2.5 years. And if the HEPA is working properly or not, you will get on a display. We had given the display of the temperature, humidity, HEPA status. Then apart from that, now I had developed the new display where you can have the particle counts, PM1, PM2.5, then the CO2 level, VOC, all these things will get displayed. What is the importance of the CO2 level? Anyone knows if the CO2 level goes high, what will be the problem? All human beings are the CO2 producers. If the CO2 level goes more than 1000 ppm, you cannot concentrate your work. So that also has to be reduced. For that, we are given the activated carbon filter and the negative ionizers. Okay, so CO2 level will come down with that. Then the ducted system, whenever you have to do the change the HEPA, That time you should do the robotic duct cleaning first. If you don't do the robotic duct cleaning and just change the HEPA, your HEPA will get choked within a week also. And that whatever the money you have spent it for the changing the HEPA will be no use. Then the keeping the AHU home in your commercial place also having the cost. So these systems saves almost 16,25,000, 24,000 in a year in operative maintenance cost. Is it not the big saving? So this you can save in a operative maintenance cost. Okay. Then the system what I had given, also having the patent certificates is there. We do the third party testings to the wherever we installed. Then this study is also published in International Journal for the Science and Engineering. Then the ISO C and 13485 and 9000 also we had taken. This is one of the product what we have developed for the making to avoid the fumigations in the operation theaters and many places. Normally we do use the foggers because of the chemicals entire your rooms get weighted, and the humidity also goes on, and your whatever the gadgets you inside the room or OT, electronic gadgets may get chances of getting the spoiled. So in these systems, O3 Gen is the ozone generating equipment. Ozone will kill all the bacteria, fungus, virus, molds because it's having the nascent oxygen. It's working like a hydrogen peroxide. Hydrogen peroxide also works on a nascent oxygen technology. So nascent oxygen to attach, they get attached to the pathogens, bacteria, fungus, virus, mold, and they will destroy that. Then now we have to talk about the ICU and NICU. All these area normally, though we are taking the lot of care, but we are not concerned much about the air quality inside the ICU and ICU. See, if you get the 20 air changes in your ICU and ICU, the air quality, what you are maintaining in operation theaters, if you give in a ICU and ICU, patient recovery will be the fast. First benefit is that the patient's recovery will be fast. Then second is the antibiotic dose you can reduce drastically. I had installed these systems in one of the CVTS ICU where after that they do the cardiac, heart transplant, liver transplant, all these critical patients where the recovery is also challenged and survival is also getting the challenge. In that area, when I had given the systems, earlier they used to require the 5 to 6 weeks to get the discharge patients. Now, after installing this, they get discharged within 2 to 3 weeks. All post-op complication will be taken care of. This system will give the 20-year changes in ICU. Then you will get activated carbon filter, HEPA filters has been given. So whatever the air is coming through the HEPA, so air quality, particle counts, air quality will be minimized, and you are getting the air changes also. So this is the beauty of the systems. In this, we are going to add now the air quality index monitoring will be also given. So you can know what is the temperature, humidity, HEPA status, particle count, CO2 level, everything can be displayed over here. Where the height is the concerns, we have the wall-mounted AHUs also. You can put the wall-mounted systems. We have where the challenges are there for the heights. We had given earlier we are using the guided airflow technology for the making the operation theaters. Air is to the HEPA, it's supplied to from the uppers, it's going to the ceiling side. Here the backward curve fan, and from this HEPA it's coming on the table level. So this type of air circulation is the guided airflow technology, also we had given earlier. Then as I told you, we had developed the monitoring systems where you can have the all particle counts, can be particle counts, HEPA status, all air quality IQ monitors will be also there. Then the operations, you can have the 2 camera visions also, and all monitors will get also synchronized to the monitors can be also synchronized. Multi-para can be synchronized over here. Then having the light controls and other things. So those things also we had developed now. So main benefit with the system that the design point of view also it's very compact, can be installed within a day, because this is the ceiling suspended system, can be installed within a day. So time for the installation or making the clean rooms is the minimized drastically. Maintenance point of view, I said you that the no routine maintenance is required. What is the maintenance now? Duct we are taken care of. AHU, there is the no pre-filters getting clean. Third thing, which is the most important, is the condensing unit, outdoor unit. So maintenance of the outdoor unit, for that any technician can look after the what if the gases come down to you have to check the pressures in the that. Then the cleaning of the condensing unit. So these are the routine cleanings which do the any AC technicians. So you have to take care of that much only. Okay, no other maintenance. You can save the money in electricity. You can save the money in AHU keeping space. Then the routine maintenance is not there, so you can save the money in that also. This is the major benefits with the saving. Tonnage point of view also know that because there is no leakages or the of the in the ducts, so you can save the money in tonnage also. Instead of 11 tons, you can have with 8 tons also. Further, this product is not just for the operation theaters. This can be given in any place wherever you want the better air quality, like ICU, NICU, IVF labs, microbiology labs, burns area. Then wherever you want the better air quality to avoid, you can give in a patient waiting also. So some area where the means air getting the fresh air is also the difficulty. We had developed the one more product, which is the TFA, treated fresh air. So I got the challenges in one of the places where the one of the hospitals they are in one of the mall. So outside there they're having the glass facade, so fresh air is not coming. So all those areas normally people do the 100% air conditioning, fully air conditioning area, but they are not getting the fresh air from the outside. So if you don't get the fresh air, what will happen? The biological burden in that area will go on increasing. Pathological what the normally growth is there, that will be high. And that because of that, patient will get the AC sickness, okay, skin allergy, and that breathing problems will be always there. To avoid that, to give the solution for that, we had developed the treated fresh air type product, where we had given the air conditioning also in that, and the HEPA filter is there. All the air which is fresh air is coming in that. We can give from the one AHU to the different around almost 15 to 16 rooms we had given the flow. So that is possible, that those things also possible with now with the new technology. So wherever you want the better air quality and the infection controls and solution for your, we can give the solution to you.